Okay, let's just unpack this for a second. Imagine you're just wandering through a totally ordinary backyard in, rural Queensland, Australia.
Right.
You're not expecting to find anything. But then you realize that this patch of red clay you're standing on holds the secret to a 55 million-year-old apex predator.
And not just any predator. One that basically rewrites the entire crocodile handbook. It sounds like a movie script,
Exactly.
but it's real. And that's what we're diving into today. The discovery centers on something called Wakkaoolithus, godthelpi.
Which is a bit of a mouthful.
It is, yeah.
Yeah.
But refers to Australia's oldest known crocodile eggshells. A team led by UNSW researchers found them, and they tell an incredible story.
So that's our mission for this deep dive. First, we need to figure out what kind of bizarre, extinct creature actually laid these shells.
And second, and this is the really crucial part, we want to show you how this tiny fragment from the past isn't just for textbooks. It's being used right now.
Actively, to help save critically threatened species today.
It's amazing. The whole story starts in a place called Murgon in Queensland. And to you or me, it just looks like a clay pit.
Yeah, nothing special.
But for paleontologists, Murgon is, well, it's basically sacred ground. People have been digging there since 1983. It all kicked off when Professor Michael Archer and his colleague Henk Godthelp got permission to start excavating what was literally a sheep paddock.
You have to admire that kind of persistence, convincing a farmer to let you dig up their field.
Well, they suspected this clay, which was at the bottom of an ancient lake, was hiding something big. And they were right.
And this takes us way back. We're talking 55 million years ago, the Eocene.
A critical time. Australia wasn't an island yet. It was still physically connected to Antarctica and to South America. The world was a lot warmer, a lot wetter.
That context is everything, isn't it? It's a snapshot of life before Australia was cut off from the rest of the world.
Exactly. And the creatures you find from that period are they're unlike anything that survived.
Okay, so let's get to the animal. The eggshells belong to an extinct group of crocodiles called mekosuchines.
And that name, Wakkaoolithus godthelpi, it's actually a really great tribute. It honors the local Wakka First Nations people on whose land the fossils were found.
And Henk Godthelp, the researcher who helped start it all.
That's right. And these mekosuchines, they are a chapter of evolution that tends to surprise people.
How so?
Well, you have to remember that Australia's modern crocs, the salties and the freshies we know today, they're pretty new to the scene.
Oh, right. They only showed up about, 4 million years ago?
Around 3.8 million, yeah. So 55 million years ago, the mekosuchines were the early game in town. They completely dominated the inland wetlands and forests.
And this is where the image of a croc just lurking in the water, it kind of goes out the window.
Completely. They didn't just stick to the rivers. They evolved into this huge diversity of roles. I mean, some got very big, up to 5 meters long, and stayed in the water.
But not all of them.
No. Professor Archer's work points to some of them becoming fully terrestrial hunters, stalking prey through the forests.
A land crocodile. That just sounds, I don't know, inefficient. Why leave the water? It's the perfect ambush environment.
That's the thing about evolution. There was a niche to fill. Back in the Eocene, Australia didn't have many big mammalian predators.
So the crocs stepped up.
The mekosuchines filled that gap. But the real shocker comes from younger fossils, about 25 million years old, found at another site in Queensland called Riversley.
And these suggest something even more bizarre.
They do. They support this theory that some mekosuchines were what researchers have jokingly called drop crocs.
Okay, drop crocs. We have to stop there for a second. That sounds like something from a horror movie. Are we talking about a giant reptile climbing trees?
Maybe not the 5-meter giants, but definitely big, powerful reptiles. Their anatomy suggests they could climb. Their legs might have been a bit different, shorter maybe, and their feet better for gripping.
So they would hunt like a leopard, waiting on a branch and then dropping down on prey.
That seems to be the ecological niche they filled. An ambush predator, but from above, in the ancient Australian rainforests. It just completely reframes what a crocodile can be.
It really does. Which brings up a huge question. How on earth do you get all of that detail? Their breeding, their behavior, from a tiny piece of eggshell found in a field.
And that's the power of evidence people often overlook. The lead author of the study, Xavier Pinetti's A. Bloss, he emphasized that eggshells are usually just treated like debris.
Just background noise.
Right. But they're actually these incredibly dense little time capsules.
It makes sense. I mean, they have to be strong enough to protect the embryo, but still porous enough for it to breathe.
Precisely. And that structure is what preserves these amazing microstructural and geochemical signals. The team used these incredibly high-powered microscopes to look at them.
So what did that show them? What are these signals in plain English?
Okay, so think of the eggshell like it has layers, almost like tree rings. And they're made of calcium carbonate crystals. The way those crystals are stacked and shaped, the microstructure, that tells you the evolutionary family of the animal.
It's a fingerprint.
It's a fingerprint. And these shells were definitively mekosuchine. So that confirmed they were laid by the ancestors of those drop crocs.
Wow.
Then you have the geochemistry. As the mother forms the shell, she's pulling in minerals from her environment, from what she's eating, the water she's drinking. By analyzing the chemistry of those layers, you can figure out what she ate, the temperature, even the humidity of the nest.
So you get a chemical snapshot of a moment 55 million years ago.
You do.
Ugh.
And it confirmed these crocs were nesting right along the edges of a big ancient lake.
And the Murgon clay itself told a wider story about that environment, right?
Oh, a huge story. It was a lush, vibrant forest, so different from Queensland today. The clay also had fossils of Australia's very first frogs and snakes.
And more than that, I think.
So much more. The world's oldest known songbirds, one of the world's oldest bats, and really telling, a whole bunch of small mammals with direct genetic links to South America.
There's that supercontinent connection again. You can see it right there in the fossil record.
Mhm.
The clay also had giant soft-shell turtles and, of course, the famous archaic marsupial Darthia murgonensis. It sounds like an absolute paradise for these crocs.
It was, for a while. But that golden age didn't last. The research from people like Dr. Michael Stein, it points to a massive continental climate shift.
Australia starts drifting north.
And the interior starts to dry out. The lush forests they needed for hunting and nesting just began to disappear.
It's that classic evolutionary squeeze. They're specialized for a wet forest, and the whole continent is becoming a desert.
Exactly. And as their habitat vanished, they were pushed into smaller and smaller waterways where they suddenly faced fierce new competition.
From the ancestors of modern crocs.
Right. New crocodile species started arriving, competing for dwindling food sources. The mekosuchines just couldn't adapt fast enough to the aridity. They lost.
Their struggle with habitat loss, it sounds hauntingly familiar. And that's the perfect bridge, I think, how we take these ancient clues and use them today. Because this whole story, it actually started long before these Murgon eggshells.
It did. You have to go back to 1975, a decade before the big Murgon digs. That's when Professor Archer found this very weird crocodile jaw fragment in the Texas caves in Queensland.
I remember reading about this. He had no idea what it was. The teeth were all wrong. He described them as dinosaur-like.
Yes, exactly. They were big, they were serrated, more like a land predator's teeth than a modern croc's. So he sent the fossil off to a specialist who identified it as an extinct type of crocodilian that was incredibly similar to fossils found in
South America.
South America. That was the first big clue. That 1975 jaw was the first proof that these strange land-based crocs were part of Australia's ancient history, long before our modern ones showed up.
It was the first concrete evidence of that supercontinent link.
It really was. And that knowledge, understanding where these animals really thrived, that is the ultimate so what for modern conservation.
Right, so how do we make that jump? From a 55-million-year-old tree-climbing croc to actually saving a species that's alive right now?
You use the fossil record to challenge your assumptions. The perfect case study is the Burmese project. It focuses on the mountain pygmy possum, Burmese parvis.
Which is critically threatened.
Critically. And they live in these tiny pockets in Australia's alpine regions. They're under huge pressure from climate change and habitat loss because their whole life revolves around deep snow cover.
So the common wisdom was that they were alpine specialists. That's just where they live.
That was the assumption. So all the conservation efforts were focused on preserving those tiny, cold mountaintops where they're barely hanging on.
But the fossil record told a different story.
A completely different story. Looking back over 25 million years of fossils, researchers found that the ancestors of these possums didn't live in the Alps at all. They thrived in temperate lowland rainforests, places like rivers lay.
So they're not actually an alpine animal. They're a rainforest animal that got stuck on a mountain when the climate changed.
Precisely. They got stranded up there during a warm, wet period. And when it got cold again, they developed these really high-risk survival tricks like long hibernation just to cope with an environment that wasn't their natural home. We were trying to save them in the wrong place.
That's incredible. So what did the scientists do with that information?
They acted on it. Professor Archer's team built a special breeding facility, but they built it in a lowland rainforest near Lithgow, a non-alpine environment.
They took the possums back to their ancestral home.
They did, and the results have been staggering. The possums are flourishing there. They're breeding, they're thriving, just like the fossil record predicted they would. Professor Archer calls it a demonstration that paleontology can give us concrete strategies to save endangered species.
By showing us where they're supposed to be?
By showing us their true ecological needs, based on millions of years of data. The past gives us intelligence.
Yeah.
The mekosuchines failed because their habitat changed and they couldn't adapt. That's a powerful lesson for today.
So we've gone from a backyard clay pit to a 55-million-year-old predator that hunted like a leopard, all revealed by a fragment of eggshell. And then we've seen how that deep-time knowledge has directly led to saving a tiny mammal today.
We have to stop thinking of fossils as just dusty old relics. They're blueprints for survival. They tell us what worked, what didn't, and why. That information is it's invaluable for conservation.
It really makes you wonder, doesn't it? Given how well relocating the pygmy possum worked, is just based on its ancient history, what other critically threatened species, struggling in habitats that are rapidly changing, what other animals could we save if we just looked back far enough to see where they truly came from? Something to think about.